So here we are. We have coupons, both square and round, in 3 different gauges. That is a 16 gauge, roughly a 14 gauge, a little bit below 1.8 millimeter, and a 6.2 millimeter, equaling a 1/4 inch material. As you see, the surface is fairly heavily corroded. Some parts more, some parts less. The task is to round the edges, but at the same time to clean up the surfaces and to remove the corrosion. We have 2 ways how we will do that, and you will see that. One is with a cross-brushing machine only, and the other one is in combination with a white belt sander. What you just saw here is we set the machine. We started with a 14 gauge, very heavily soiled on the top, set the machine to the thickness, adjusted a little bit for the brush pressure, because with thinner materials you are quickly in the conveyor belt, and put the part on the machine. You should always run your parts in some sort of an angle. In this case we ran diagonally in order to get the maximum rounding on all the edges. Of course, with round parts that's irrelevant. Here you see the part coming out. You see the white lines on the edges for the radius, and also the reasonably blank surface, metallically blank surface. We mark each of the parts as we run them, with the feed rate that we ran and what the process was. And then later on you will see that we are going to run parts in 2 processes, first the white belt sander and then the cross belt, and then we will mark that also. So here's the reverse side of the 14 gauge, and you see how it comes out. This was the cleaner side that had less corrosion and less pitting from the corrosion, and of course the results immediately reflect that also. If you wanted to remove all of the pitting, you would have to very aggressively surface grind it, probably with several grids, multiple heads. We can discuss it once you have the samples, to find out what it is that you really want to achieve. So next we move on to the 1/4 inch, the round one. We are mixing it up a little bit, and I apologize for the camera, because I'm holding the camera while I am doing all these samples. Here we just set the machine to 1/4 inch or 6 millimeters, and at the same time we are adjusting the brushes down for a more aggressive edge rounding. Why can we do that right now? Because the part is thicker and it has more distance to the conveyor belt. So we are not at risk of running into the conveyor belt. There you see the part coming out, and again, this is the corrosion side. It does not remove all of the mill scale. To remove mill scale, the most efficient way is really blasting, not even grinding with a belt sander. I assume that you do not want to necessarily remove the mill scale. You just want to have a surface that is paintable, and that would be very paintable as it is. And that the round defects you see in the surface are from the rolling mill, of course. So that was one side, and then we're going to run the reverse side, which again is going to be the clean side. It's going to come out a lot better. What we did actually for the reverse side also is we set the brushes down some more and made it even heavier. As you noticed, the setup is so quick that you can put the part on the machine, and while it is running up to the brushes, I do the settings. Now, I don't recommend that necessarily for everyday use, but this is very often how I do things in order to save a little bit of time. So now we are taking a heavily soiled part. This is the 14 gauge, and we are going to run it through a belt sanding head. This is a combination machine we are just using. It has a large 9-inch contact roll, and we have a very fine grit on there, because all I want to do is to remove the rust without removing too much material from the surface and without making too much of a grain structure. So this is a machine that has first a white belt sander, and then it has these rotary brushes which are on a carousel and which can turn in itself, but we have those turned off because this is not what we want to demonstrate here. Here you see the grain from the 180 grit and how it cleaned up the surface. Of course, more than a cross belt would clean up the surface, a little bit more, as it is a surface grinding process. So now that we have the surface clean, we can speed up the throughput a little bit through the machine, and again have the settings lighter so that we are not too heavy into the conveyor belt. And there you have these results. Now you have an even more plain surface. No mill scale on the 14 gauge, of course, because it is cold roll. And yeah, bad camera, but anyway, you see a little bit of the edge, and we are doing the other side. First the belt sanding. I'm grabbing my pen, and then subsequently, after it comes out of the machine, it takes quite a while for it to come out of the machine because you have a lot of lengths, of course, in that machine. It comes out of the machine, we are going to run it through the cross belt machine. I think that for most purposes a cross belt machine alone should be a good solution for you. You can combine a white belt sander with a cross belt machine, then it would be all in one throughput. That of course is very efficient. It is more economic in terms of the investment and more flexible in terms of the use if you actually buy a standard commodity single belt sander, white belt sander, 44-inch wide, can be bought for $23,000, and then a standalone cross belt machine for about $53,000. So the combined investment would be $75,000. If you do this in a single machine, where you have both components in one machine, it would have a touchscreen control also, and it would be an investment of $89,000. So, on we move. I'm looking for parts here, what to do next. We are now setting the machine for 1/4 inch, and we are going to run the 1/4 inch square with both processes. And again, as you saw me in between marking the parts are marked for the sequence, whether they have been run through a white belt and through the cross belt, or just through the cross belt, so that you have a fair comparison between the two processes. So here comes a 1/4 inch. 1/4 inch square was not all that contaminated, but of course it is hot rolled and has mill scale again. Cleaner surface, but after surface grinding with the 180 grit, you have a very sharp edge. This would A, cut you, and B, it would not paint very well at all. But after the edge rounding, you have enough radius on there to have full paint coverage. You will reduce corrosion if you ran parts through a salt spray test, not doing anything, and edge rounding. You would see after 300 hours a difference of about 50% corrosion on edge for where you did nothing, and about 2 to 3% corrosion only after you run it through the edge rounding. You actually are making the edges worse if you only surface ground them, if you only use the white belt sander to clean them up, because you would actually sharpen the edges and create a slight secondary burr. So this is a clean side now where you see a very bright blank mill scale with material only removed from the edge because we have this large 9-inch contact drum, fairly soft paper also with a 180. And here it comes out. We are removing a little bit more of the mill scale. We're perforating it a little bit, but we're not removing it. And we have a very clear radius on the edges. You see the white lines, which are the reflection of the light in the radius. And from experience, we can assure you that this part will have good paint coverage and will have also no dark lines if you paint it with brighter colors like white and yellow due to lack of coverage on those edges. We mark the part and of course in the sequence, and again give you the speeds. CB stands for cross belt, WB stands for wide belt. I think those pictures in large part speak for themselves. Now we're going to take an interesting test. We have the last two parts, which are the 16 gauge. And we are going to take the less contaminated one and put it through the wide belt sander. And then afterwards we'll take the more contaminated with rust contaminated square and only run it through the cross belt. So it isn't that we took the part that was dirtier anyway and ran it through the wide belt. On the contrary, we made the test more relevant by taking a part that was dirtier, it showed more corrosion, and only ran it through the cross belt. So it is important, and that's good why we have this video, so that you see the contamination before and after to get a reflection of the actual performance. So here, even with a wide belt sanding, you still see some pits in there. If you wanted to get those pits out, you probably first would have to grind it with a 50 grit or a 60 grit, and then go to 120 grit, and then go to a cross belt. If you just ground it with a 60 grit, you probably would see those lines in the paint afterwards, depending on how much solids you have in your powder or in your coating process. So here we are running the part through the cross belt machine, and of course it comes out very nice, very clean with a dual process. And again, we mark it. Run about 3 feet a minute. You should, in steel, you can run between 2 feet and 4 feet per minute to get decent edge welding. I heard from Rod Johnson that you wanted to have more radius, so I choose the middle to the low range of that. You could get even more edge rounding if you ran it at 18 inches a minute. Now 18 inches a minute in a part of that size, which may not be reflective of what you do, would still be probably close to 1,000 parts single side per hour easily. So now what we're doing here is we are reducing the speed to 24 inch in order to do this more contaminated part and get a cleaner surface and get a little bit more radius. So you will experience that too. And again, if you think about a part like this, you can probably put them 5 wide into the machine, and you have approximately 12 seconds per part throughput time, and you can stagger them a little bit. So that would be 5 by 5, that would be 25 parts per minute, or roughly 1,500 parts per hour. Now you're not going to run them obviously edge to edge, and you can't load them that fast, so a realistic quantity for a part like this would be somewhere between 1,000 and 1,200 parts per hour. As you have larger parts and you want to have throughput, you may want to consider to go to a 64-inch machine, as it gives you more throughput by being able to put medium-sized parts, large parts in part, side by side. So, and here goes the second side of the 16 gauge square, which was the cleaner side, and that will be also reflected in the results again. And that pretty much concludes the test on the samples that you sent to us. The specs that you see here on the parts are not corrosion. They are a little bit of rubber because with a thinner material we are in the conveyor belt, and they will just wipe off. So thank you very much for sending the parts, and we put them in the mail on Monday. Thank you.